There's some really great apps in the App Store and Google Play Store. And when I was consulting building apps for people in business, they'd show me augmented reality apps like Pokemon Go or the Uber app with its live location tracking, and they'd ask, can I get an app like that for my business? Welcome to the sixth and final install. When my clients asked me about pricing, I would usually work from a basic rate per screen. In 2017, that rate was about $5,000 per screen, and by a screen I mean like settings screen, a login screen, even just a pop-up for a social share. Each chunk of user experience, ballpark $5,000. If it had to fetch data from a back-end service, double it. If it had interactive editing, not just display, double it again. Animations, double it. So basic apps are cheap, but by the time you start adding in a lot of things, that bill very quickly adds up. Now, with powerful apps, the answer to all these can you and how much questions is basically yes, and it depends. And that is the risk, because innovative app features are unknown. Out-of-the-box apps fetch data from the web. They store some local configuration, such as passwords and preferences, and then they just display up-to-date information relevant to you. Honestly, the apps that I've worked on, they're not cut and paste, but this out-of-the-box regular type behavior is pretty much all they needed. The trouble is sometimes we see things in apps that are in the Apple App Store or Google Play Store, like that Uber app, like that Pokemon Go app, and we see these fancy cameras, but they don't just come standard. Apple's iOS and Google's Android provide APIs for these, but building the features on top of it means extra complexity. And if apps are so expensive, are they really worth it? That question kind of gets to the heart of how apps are different from websites. When I was running my image sorting app startup in 2017, I created an algorithm to derive human meaning from photographs, and you can see it there on the screen. That was Lord Mayor of Brisbane City presenting my co-founder and I. I'm on the right there with a prize. Basic AI classifiers could tell if a photo was a cake or a beach, but our secret sauce for our app was that it could tell if it was a birthday cake or a beach holiday. So at the core of our app, we had this technology and we patented it. It was complex to build. It ran on the device itself and protected our users' privacy. There's other features like notifications that are kind of a killer feature for apps. They can really drive customer attention and engagement. In general, you can't get mobile notifications in a web app. I will at some point do a complete session on notifications. But that is the power of a custom native app. They require that native code that your developers are going to work on. And in previous posts, I have talked about the different types of apps. I've talked about native apps, which are the ones you download from the Apple App Store, the Google Play Store. And we learned about web apps, which really just optimized websites, especially for mobile. And we also learned about hybrid apps, which are kind of halfway between web apps and native. They have some of the features of native, but the flexibility of a web app. So one of the reasons to consider an app is because of the power features that are typically missing from a website in general. But they do require building of packages per platform. If we look at this Apple Music app, now this is a listing in the Google Play Store. So think about that for a minute. What programming languages would Apple's engineers be using potentially to create this app? Because Apple uses its iOS languages, right? But here we're building an app for the Android platform. So that means that it's likely to be Kotlin or Java. Even when Apple writes an app, if it's going on to the Android platform, it has to be using the Android APIs, and it has to be coded for that particular platform. So if we think about it, what are those differences? Well, on iOS, for example, StoreKit is the API that's used by Apple and provided to developers to create in-app purchases. But on Android, it's the billing API of Google Play that's available for that purpose. On Android, we use Firebase Cloud Messaging to do notifications, but on iOS, notifications are sent via APNS. So we've got these deep differences. There's a matching of language, the development environment, the deployment of different packages, and I've been working in iOS development since 2010 or so, and that has been consistent throughout those decades. And the thing is about these platform technologies, they are the ones that are going to be able to provide powerful, feature-rich mobile apps on the iPhone and on the Google Play Store. The reason for those differences across iOS and Android is that each platform vendor has built what they believe is the best offering, and it uniquely matches the value for customers of their device. Apple makes premium devices that are more expensive, but they feature greater privacy, they have high-end, tightly integrated hardware, and they access curated content in the Apple ecosystem. They have custom hardware and software, their own chips, and it means that often iOS devices can outperform what you would think would be equivalent premium Android handsets, like say a 4-core Android might be outperformed by a 2-core iOS device just because of that hardware matching. But Android is a good place to start when you're launching free apps that target large audiences of value-conscious users. People who are shopping, they're looking out for those deals, and it's important if you're doing an app like that to go for those Android devices because you're going to make your app freely available. I talked in previous sessions about the difference between apps that are enabling commerce versus ones that have the value inside the app itself. Android devices often have more CPU power and configurability at a lower price point, so they suit tech-savvy tinkerers, but they also power a large fleet of low-price commodity phones, and they're used throughout the world. It's got a huge install base, but often they're very old devices with much older versions of the Android operating system, the so-called long tail. And often those older, smaller, less powerful devices, they might not necessarily be the customers that are going to generate the revenue for you. So you have to balance that issue off with Android development. Another big difference is Android is much more permissive regarding security, and generally interoperation between apps and services on Android is more straightforward due to this permissive approach. But on iOS, the opposite is true, and Apple's continuing focus on security can make background app operation and different kinds of hardware use wind up requiring engineer teams that have specific iOS experience in order to make them a big success. A recent example was the COVID-19 tracing app here in Australia, which just didn't work at all on iOS due to developers not understanding Apple's security model. And the minister in charge of the app famously claimed that Apple was preventing their COVID-safe app from accessing Bluetooth, but bug reports actually showed that the app didn't correctly use the iOS Bluetooth API, so they were just not working in terms of Apple's security and privacy model. Looking back at the history of Android versus iOS, early Android phones used Dalvik, a Java virtual machine embedded in Linux. This allowed apps to be secured via a virtualization layer. It was similar to the way Java applets worked in browsers, and also the way that the Java midlet security model worked in old Nokia phones. Android now uses ART, the Android runtime, but it's still got that isolating application layer between the app space and the lower level system of the phone. Again, in Android, a manifest file also controls all the entry points to the app, similar to a Java web app. So on iOS, however, code, even app code from third-party apps, runs natively on the CPU, and they use a sandbox model with kernel-level mechanisms to secure those apps from even seeing or accessing files from other apps or from the